Here's a number that stops people. Research into AI incidents consistently shows that the majority of documented harms weren't caused by the AI malfunctioning. The systems worked, they performed to specification, hit their accuracy targets, and passed their tests. And they still hurt people. So sit with that for a second. If your model can be entirely correct and still cause serious harm, what exactly is your testing catching? That's the question this chapter answers, and it's why NIST spends so much of part 1 on harms rather than on failures. Those are different words for a reason. So here's what you'll get. You'll learn to see AI risk across 3 levels: individual, organizational, and societal, and understand why most frameworks only see the middle one. You'll learn to classify harms as direct or indirect, reversible or permanent, and why reversibility should drive your rigor more than probability does. We'll cover technical, operational, strategic, and reputational risk, environmental impact, which nobody talks about, and the gap between intended and unintended consequences, which is where the interesting failures live. By the end, you'll be able to look at any AI system and ask the question that actually matters. Not will it break, but who pays if it works exactly as designed. Let's get into it. So let's start on familiar ground, the risks your existing register can already hold. Technical risk first. Does the thing work? Accuracy, robustness, security, availability. Your model returns wrong answers. It falls over under load. Someone poisons the training data. These are recognizable, and your engineering teams are reasonably good at them. Operational risk next. Does the thing work here in our actual business? This is where the interesting failures live. The model is accurate, but the workflow around it is broken. Staff don't trust it or trust it far too much. The integration silently drops fields. I once saw a forecasting model performing beautifully in testing and disastrously in production because in production it received dates in a different format and nobody had checked. Then strategic risk. This is the one people miss entirely. Did we bet on the wrong thing? You build a capability on a vendor who gets acquired. You optimize a process that's about to be regulated out of existence. You spend 18 months and 2 million on a model that a general purpose tool now does for free. Notice how these escalate. Technical risk costs you a fix. Operational risk costs you a project. Strategic risk costs you a market position. So ask yourself, which of those 3 does your AI review process actually examine? Usually just the first. So let's talk about reputation, because AI failures behave differently here, and I don't think people appreciate why. Here's the mechanism. A normal outage is boring. Your site was down for 2 hours. Nobody screenshots that. But an AI failure produces an artifact, a screenshot, a quotable line, something a person can share with 3 words of commentary and watch it travel. And AI failures are narratively perfect. They're absurd, they're often funny, and they confirm something people already suspect, that these companies deployed something they didn't understand. Think about the airline whose chatbot invented a bereavement discount policy. The tribunal held the airline to it. Now, financially, that was a small sum. Reputationally, it became the case study everyone cites. Years later, it's still the example. And here's the part that should worry you. The reputational damage was disproportionate to the actual harm. One customer, modest money, global story. So the traditional risk calculation, likelihood times impact, badly underestimates this. Because the impact isn't the incident. The impact is the story about the incident. Which leads to a practical point. Ask your team, if this system's worst output appeared on the front page with our logo next to it, could we defend the decision to deploy it? Not the output, the decision. If the answer is no, you found something. So now we go to the level that most risk frameworks quietly skip: harm to the individual person. Let me be concrete because abstraction hides this. Think about a specific human being. She applies for a mortgage. The model declines her. She doesn't know why. She doesn't know a model was involved. She can't appeal because there's nothing to appeal against, just a decision. What did that cost her? The house, maybe. But also, she now believes something about herself that may not be true. She'll self-select out of applying elsewhere. Now multiply that. The candidate whose CV was filtered in 100 milliseconds. The patient whose symptoms didn't match the training distribution. The parent flagged by a benefits fraud model who spent 2 years proving a negative. And here's what makes this different from other harms. It's asymmetric. To you, that's one false positive out of 100,000, well within tolerance. To her, it's 100%. She experiences your acceptable error rate as a total event in her life. So when someone tells me their model is 99% accurate, my question is always the same. Tell me about the 1%. Who are they? Are they random? Or are they always the same kind of person? Because if the errors cluster, you don't have an accuracy problem. You have a fairness problem wearing an accuracy costume. So now the level your board already understands, harm to your organization. The obvious ones first: financial loss, regulatory penalty, litigation, remediation costs, which are always larger than anyone budgets because you're not just fixing a model, you're re-examining every decision it made. But let me point you at the less obvious ones, because those are where the real damage sits. Trust erosion inside the organization. This one's underrated. One bad AI deployment and your entire AI program slows. Every subsequent project now carries the ghost of that failure. I've seen a single incident set a company's AI ambitions back 3 years, not through regulation, but because nobody would sponsor anything. Talent. Your best people don't want to work somewhere that shipped something harmful. They leave quietly and they tell their networks why. Opportunity cost. While you're managing an incident, your competitor is shipping. And then dependency risk. You built your process around a model. Now the model is wrong and you've lost the manual capability. Your people can't do it the old way anymore. Nobody remembers how. So here's the question I'd put to your executives. If we had to run this without the AI tomorrow, could we? If the answer is no, you have a continuity problem you haven't logged. So here's the level that makes people uncomfortable, and I understand why. It feels like someone else's problem. Let me argue otherwise. Think about what happens when it's not one lender using a model. It's every lender using similar models, trained on similar data, reaching similar conclusions. Individually, each is making a defensible commercial decision. Collectively, they've built a wall around an entire community and nobody chose to build it. There's no villain, there's just correlated logic at scale. That's an emergent harm. No single organization caused it, no single organization can fix it. Or think about information. Each platform optimizes for engagement. Each is rational. The aggregate effect on public discourse is something nobody wanted and everyone contributed to. Now, why should this be on your risk register? Two honest reasons. First, because NIST explicitly says it should. Individuals, organizations, and society. It's in the framework's stated purpose. Second, and more practically, because societal harms become your harms, eventually. Regulation is society's immune response. Every heavy-handed rule you resent started as a societal harm nobody addressed voluntarily. So the pragmatic case is simple. Assess societal impact now or have it assessed for you later by someone with subpoena powers. So let's talk about the one nobody raises in AI risk meetings: environmental impact. Here's the reality. Training a large model consumes substantial electricity. Running inference at scale, millions of queries a day, consumes more over time than training ever did. Data centers consume water for cooling, often in regions where water is not abundant. Hardware has a manufacturing footprint and an end-of-life problem. Now, I'll be honest with you about why this rarely lands. It feels distant, and the numbers are hard to get, and nobody's asking. But watch the direction of travel. Sustainability reporting requirements are expanding across jurisdictions. Your ESG disclosures are becoming assured rather than voluntary, and your AI compute is showing up in someone's Scope 3 calculation whether you've measured it or not. Here's a practical framing that lands better with executives. It's a cost conversation. That inefficient model you're running, the one that's 10 times larger than the task requires, is burning money on every single call. Efficiency and sustainability are the same lever here. I worked with a team who swapped a large general model for a small fine-tuned one on a narrow task. Same performance, a fraction of the cost and the footprint. So the question isn't, do you care about the planet? It's, do you know what your AI actually consumes? Most organizations genuinely don't. Right. This is the video that gives you a tool you'll actually use. Two axes for classifying harm. First axis, direct or indirect. Direct harm comes straight from the output. The model declined her loan. Clean line of causation. Indirect harm comes through a chain. The model shaped a recommendation, which shaped a human decision, which shaped an outcome. Harder to trace, often larger. Second axis, and this is the important one. Reversible or irreversible. Can you undo it? Let me show you why this matters more than probability. Take a spam filter. Wrong occasionally, but you check the folder, you retrieve the mail. Reversible. Now take a model recommending which patients get an urgent scan. Miss one and the disease progressed. You cannot unprogress it. Time doesn't reverse. Same accuracy on paper, utterly different risk. Now here's the trap, and I've seen serious people fall into it. Reversible in principle is not reversible in practice. Yes, technically the wrongly rejected candidate could reapply. Will she? She's got another job. She's moved on. The correction mechanism exists and nobody uses it. So here's the rule I'd give you. Let irreversibility drive your rigor, not likelihood. A rare but permanent harm deserves more attention than a frequent but correctable one. Ask of any system, what's the worst thing here that we cannot take back? So let's talk about intent, because this is where the genuinely interesting failures live. Intended consequences are easy. You built the model to detect fraud, it detects fraud. Fine. Unintended consequences are what happens when the system succeeds in a way you didn't picture. And notice, I said succeeds, not fails. Remember the recommendation engine optimized for watch time? It worked brilliantly. Nobody intended it to learn that outrage is engaging. Nobody wrote that. It emerged from doing the job well. Or take a hospital that deployed a model to reduce readmissions. It worked. Readmission rates fell. It turned out the model was flagging patients for follow-up based partly on who was likely to comply, which quietly meant less support went to the people who needed it most. Target hit. Intent betrayed. There's an old idea here that predates AI by decades. When a measure becomes a target, it stops being a good measure. AI industrializes that problem because AI optimizes harder and faster than any human process ever could. So here's the discipline. Before you deploy, run the exercise. Assume this system works perfectly and achieves its metric completely. Now, what breaks? Who games it? What behavior does it reward that we didn't mean to reward? That question catches more real risk than any accuracy test I know. So let's ground all of this in what NIST actually says, because you should know the source language. NIST groups harms into 3 buckets, and you'll recognize the structure now. Harm to people. This covers individual harm, things like civil liberties, rights, physical or psychological safety, and economic opportunity. It covers harm to groups, such as discrimination against a population subgroup, and harm to society, like democratic participation or educational access. Harm to an organization, business operations, security breaches, financial and reputational damage. And harm to an ecosystem, interconnected elements, the global financial system, supply chains, natural resources, the environment. Now look at that ordering again. People first, organizations second, ecosystem third. That's not alphabetical, that's a statement of priority, and it's the opposite of how most corporate risk registers are built. Here's how I'd use this practically. Take your current AI risk template and hold it up against those three categories. Can it hold harm to a group? Can it hold harm to an ecosystem? Or does every field ask about impact to us? Most templates I've reviewed can only hold the middle bucket, which means two-thirds of NIST's harm landscape is invisible to your process before you even start assessing. Fix the template first.